Welcome to Mr. Vaughn's classroom, where math is made so easy, even I can do it.
Before we get started on today's video, I'd like to ask you to please hit the subscribe button so you'll know when I add new videos. Give this video a thumbs up and engage with a comment below. Today's video is on Unit 2, Congruence, Lesson 1, Congruent Parts, Part 1. The learning goal in today's video says let's figure out what the corresponding sides and angles in figures have to do with congruence. The glossary term that we're concentrating on for this video is corresponding parts. Corresponding parts are the matching parts of an original figure and its scaled copy. Scaled means having a different size, bigger or smaller. So we can see in the pictures on the right side, the top triangle is smaller than the bottom triangle. So it's scaled copy that are in the same relative positions. The parts could be points, segments, angles, or distances. When two figures are congruent, remember, when they're congruent, they are the exact same size. When two figures are congruent, all of their corresponding parts are congruent. So that is an important difference that we want to make sure we pay attention to in today's lesson. Here, because the top triangle is smaller than the bottom triangle, we can say all of these features are corresponding, but we can't say that they're congruent because we have different size shapes here. If we were to say two shapes were congruent, they were the same size, then we could go that extra step and say, okay, well now all the corresponding parts of two congruent shapes are also congruent. But just because things are corresponding does not mean they're congruent. They have to be corresponding parts of congruent shapes. So for example, in triangles ABC and DEF, point B corresponds to point E, segment AB corresponds to segment DE, and angle BCA corresponds to angle EFD. The summary of what we're going to see in today's lesson: if a part of the image matches up with a part of the original figure, we call them corresponding parts. The part could be an angle, point, or side. We can find corresponding angles, corresponding points, or corresponding sides. Remember, corresponding is not saying they're the same size, it's saying they're in the same relative position. If two figures are congruent, then there is a rigid transformation, such as translations, rotations, or reflections, that take one figure onto the other. The same rigid transformation can also be applied to individual parts of the figure, such as segments and angles. Because rigid transformations act on every point on the plane, therefore the corresponding parts of two congruent figures are congruent to each other. Using a translation and a rotation, we can take quadrilateral ABCD to quadrilateral PQRS. Now that we know the two figures are congruent, we also know that all the corresponding parts are congruent. Each of these statements and more must be true. Angle P is congruent to angle A. Segment BC is congruent to segment QR. Angle D is congruent to angle S. And segment PS is congruent to segment AD. There are 3 learning targets in today's lesson. This is what you want to keep in mind and look out for as we do the practice problems. Once we're done with the practice problems, we'll come back and review these just to make sure you understand everything you need to in order to be prepared moving on to the next lesson. Learning target number 1, I can identify corresponding parts from a congruence statement. Learning target number 2, I can use rigid transformations to figure out if figures are congruent. And learning target number 3, I can write a congruence statement. Now that we're done with the introduction, let's go take a look at practice problem number 1.
This is a big, beautiful problem. A lot of people are talking about it. And we're going to have a solution, a tremendous solution, the best solution.
When rectangle ABCD is reflected across line EF, the image is DCBA. How do you know that segment AB is congruent to segment DC? So they're talking about taking this rectangle and reflecting the entire thing across that center line EF. So if we do that, we're going to get an image that looks like pretty much the same thing. And now we can label it. Well, point A reflects across to where D is. Point B reflects across to where point C is. Point C reflects across to where point B is. And point D reflects across to where point A is. Point F is still in the same spot, and point E is still in the same spot. Now the question is, how do I know that segment AB, this segment over here on the right, is congruent to DC, this line on the left? So these segments here. Choice A says that a rectangle has 2 pairs of parallel sides. That is true. But parallel does not mean congruent. So just because we have pairs of parallel sides does not mean we have congruent sides. So A is incorrect. Choice B. Any two sides of a rectangle are congruent. Well, if we're saying any two sides, then you would be saying that the top side and the left side are congruent, but that's not necessarily true. And unless the rectangle is a square, it's not going to be true. You're 99% of the time, you're going to have a side that's longer than another side. So non-parallel sides don't have to be congruent. So B is incorrect. Choice C. Congruent parts of congruent figures are corresponding. Well, that's true, but that does not prove that the line segments are congruent in the first place. That's what they're actually asking us to prove. They're asking us to prove that they're congruent, so we wouldn't be able to use a statement that says they're congruent. We need to know how we know that. So C is incorrect. And finally, choice D, corresponding parts of congruent figures are congruent. And that's exactly what we were told multiple times in the introduction. If I know that all I did was a rigid transformation, then corresponding parts of these congruent figures are therefore congruent. So D is the answer that we're looking for. I hope this made sense to you. But if you still do have any questions, please feel free to leave a comment below. Now let's take a look at practice problem number 2.
Folks, this is a very simple problem, the best problem. Nobody knows more about this kind of problem than me, believe me.
Triangle FGH, meaning the bottom triangle, is the image of isosceles triangle FEH, meaning the top one. After a reflection across line HF. So this line crossing right here in the middle. Select all the statements that are a result of corresponding parts of congruent triangles being congruent. Now, one thing they've pointed out for you is that FE is congruent to HE. So this little symbol that you see means congruent. And the reason that that's true is that the term isosceles, triangle, means two sides are congruent So, knowing that, let's look at our choices. First, we have choice A, EFGH, which is the outside of these two shapes, is a rectangle. The thing about a rectangle is a rectangle has four 90-degree angles. These are not 90-degree angles. So this is not a rectangle. It is a parallelogram because it does have two pairs of parallel lines, but it is not a rectangle. Option B, EFGH has four congruent sides. Well, we know because of these little indicators right here, these little single lines, those two lines are congruent. Because we created the bottom triangle by reflecting the top triangle over the middle line HF, that means these two sides on the bottom, because these are congruent shapes, the corresponding sides are also congruent. So that means we have 1, 2, 3, 4 congruent sides. So B is correct. Option C, diagonal FH, so that is this center line that I had highlighted in green, bisects angles EFG, so that is the right side of this diamond, and EHG, which is the left side of this diamond. So, because FH is the line of reflection, it's also the bisector. So C is correct. I have my triangle on top, I have my triangle on bottom. They are split by FH, so therefore the angles made up by the sides of those two triangles are being bisected by that line of reflection. Option D, diagonal FH, so again, this middle line that was the line of reflection is perpendicular to side FE. We're talking about this top right side of the triangle. Well, we need to remember that perpendicular means 90 degrees. This is not a 90-degree angle. This dashed line would represent a 90-degree angle. So D is incorrect. And then finally, choice E, angle FEH. So we're talking about this top angle is congruent to angle FGH, which is this bottom angle. Well, we know corresponding angles of congruent figures are congruent. And since the top triangle was reflected down to make the bottom triangle, these angles are corresponding. They are corresponding angles of congruent shapes. Therefore, the angles are also congruent. So E is correct. I hope all of the diagrams and explanations here have helped make this make sense to you. But if you do have any questions, feel free to leave a comment below. Let's go ahead and take a look at practice problem number 3.
A lot of people are saying this is a hard problem. It's not. It's a tremendous problem, the best problem. Nobody solves problems better than me.
Reflect right triangle ABC. So we're talking about this triangle they're giving us right here. They want us to reflect it across line BC, which is this line right here. So if we do that, then point A is going to reflect across B and become A prime. And now I have this triangle, A prime B C. They want us to classify the overall triangle AC A prime. So they mean all the way around A C A prime. And explain how we know. Well, the first thing we know is that because we did a rigid transformation, in this case, that was a reflection, then that means triangle ABC is congruent to triangle A prime BC. Because we know these two triangles are congruent, therefore, segment AC is congruent to segment A prime C. Since we know that at least two of the sides, maybe the bottom is as well, but we don't know for sure, because we know two sides are congruent, triangle A, C, A prime is an isosceles triangle. So this is how we can make a statement about what we know. We simply go from what information we know for a fact. We know that we did a rigid transformation because we did a reflection. Because we did this rigid transformation, then the blue triangle is congruent to the yellow triangle. Therefore, because those two congruent triangles, we can say corresponding parts of congruent triangles are also congruent. Therefore, AC is congruent to A prime C. So now that we're looking at the big triangle, if those two sides are congruent, then anytime you have at least two sides that are congruent, you have an isosceles triangle. I hope this explanation and these diagrams and coloring help you understand this practice problem. If you do still have any questions, please feel free to leave a comment below. And let's go back to the learning targets, review them so that you're ready before you move on to the next lesson. So let's review the learning targets. We had 3 of them in this lesson. Number 1, I can identify corresponding parts from a congruent statement. This simply means when they tell you two figures are congruent, then can you identify the corresponding parts? Can you identify which sides are congruent? Can you identify which points are congruent? Can you identify which angles are congruent? Learning target number 2 says I can use rigid transformations to figure out if figures are congruent. So this means you understand that translations are moving it up, down, left, or right. You understand that rotations can be clockwise or counterclockwise. And you understand that reflection has a line of reflection that the shape is flipped over. And now, understanding those 3 rigid transformations, you can determine, can I use those 3 transformation types to go from the original to the image? And do you understand that if you can, then you can say that those figures are congruent? And if you can look at them and say, no, it's not possible for me to use those 3 rigid transformations to turn the original into the image, then you know that they are not congruent. And learning target number 3, I can write a congruent statement. This is where, like in that last practice problem, we say something like, well, because we know these triangles are congruent, then we know that this side and this side are also congruent. That is writing a congruent statement. And to make it shorter, understanding that that symbol for congruence is the squiggly line with the equal sign underneath it. When you see that, you are saying that those two things are congruent to each other. I hope you have found this video helpful. If you have, please give it a thumbs up and engage with a comment below. In the bottom left of the screen, you should see another video that YouTube is recommending to you. And in the bottom right corner of the screen, you should see the subscription button for the channel. It would really help out if you would subscribe. I look forward to seeing you in the next lesson.